System databases and their secrets, or a deep dive. I started this particular presentation, was going to focus more on a particular database, which I'll mention later, but I started to realize system databases to me are kind of fun, and there's a lot of little things that some people know, some people don't know, and I'm not going to cover everything. I realized as I was putting this together that each database itself could be an hour-long talk, but I'm not that creative, and I didn't really have that much time with it, so bear with me. So why is that not advancing? So who am I? I know some of you. I recognize some of the faces and some of the names. Hopefully you recognize me back. Those who don't, I consider myself operations side DBA. That basically means I'm concerned with keeping your databases up and running. I do write queries and I do write code, a lot of PowerShell stuff these days, but I'm more focused on keeping things going. Independent contractor, which means I get to take off as much time as I can afford, which in these times of COVID is both a plus and a minus. I like to describe myself as a problem solver. I like to solve problems. Give me, your database is slow. How can I solve that? Give me you need high availability, but you only have a VPN that connects once a day. How can I make that work? Stuff like that. I'm a caver. Some of you know that. I like to crawl through holes in the ground. And yes, I do know a body part from the hole in the ground. I'm an author. My book, Lessons Learned in the Field, combines discussions of airplane crashes, cave rescues, and database disasters. So it's kind of a fun book out there, and if enough people buy it, eventually I can afford a cup of coffee. So, and I've been doing a lot of writing for Redgate these days. The funny thing is, it all involves SQL Server, but it's all about PowerShell. So if you want to check out PowerShell, go check it out. I've been having a lot of fun with PowerShell, and I'm going to say any DBA out there who's not learning PowerShell, you really need to pick it up. It's just, it makes life so much easier. And I actually use a couple examples in tonight's presentation. Enough about me. So what are our goals? What are the system databases? I know you all say, well, Greg, we know what they are. I might surprise you here, I might not. A little proper care and feeding, not much there. It's going to be the simple caveat, back things up. Go into a deeper dive. And then the model database. This is kind of my favorite one, and I'm going to show you some examples there, which I haven't even touched all the possibilities, but I've realized I really like the model database because I think most people just kind of overlook it. And then finally, if there's questions at the end, I'll do my best to answer them, or at least make up answers that sound good to me. So what are the system databases? Master, MSD, TempDB, model. Now at this point, I would do a show of hands, raise your hands. Is that all the system databases? Anybody want to jump in and give me a thumbs up, thumbs down, a yes or a no? It's not. And this is the part that surprises folks. There's actually one more system database. Let's see, someone said something in the chat. There are more. Resource database, exactly. I'm going to, if I remember, I will show at least one example of that. But this is the database that I'll tell you 99% of people don't know about. And honestly, you can't do anything about it. So it's kind of okay not to know anything about it, but it is out there. So again, let's advance this. So the master database, this is obviously the most critical one. Back it up anytime you make critical changes. When I go into clients, I can't tell you the number of times I see that they've never backed up their master database, let alone their user databases. But this is the one where your critical information is. This keeps track of all your other databases. If you lose this database, you don't necessarily lose the other databases, but you lose all the meta information, and it can take a lot of time to rebuild that. So in my systems, we tend to back them up on the weekend. It takes 30 seconds, not a big deal. Or for example, and this has saved my bacon a few times, if I'm doing a CU, applying the latest CU or something like that, I'll back up the system databases. Yes, Microsoft says, oh, we have backup plans and like that, but I like to have an extra ace up my sleeve if I need to. So what's in the master database? If you look in there, and I'm going to try to do some live stuff in this presentation also, oops, I already gave away this. There's really not a whole lot there. There's a couple of tables, something like that. Not much there. You start to say, oh, it's mostly views. Now, I like views. I know a lot of DBAs don't like views, and there's good reasons not to like them, but I go back to what Cod, when he was describing the original SQL RDBMS design, A view is just really a materialized table. So we look at the tables, okay, and I have to wonder, why these 5 tables? I've never quite figured that out. I need to look back into that, but there's very few tables in the master database that we actually see. Bunch of views, a lot of good stuff. And we can see, different schemas, information schema, the sys schema, scroll down, stuff like that. Now, I'm a curious person. I like to know what's going on behind the scenes. So I want to see what that is. And very strangely, I can't script that out. There's no script option in my drop down here. Well, that's kind of annoying. I didn't like that. So I started poking around and I realized, well, we're not just GUI jockeys. We're DBAs. We actually can type things once in a while. We don't have to use the interface. And if I run this command, get the object definition, give it the object, voila. All of a sudden I have all the text, and that's what this is. Basically, I took out the select create view, but sys file groups basically does this. But I can't actually run it this way because I run into other problems where I have other objects that are not hidden to me. For example, I have this table it's joining in, guide refs, sys guide refs. Okay, well, let's see what that does. I can't select from that either. So suddenly there's these objects that are part of views and part of other objects that I can't get. Now I can certainly select from the file groups. Pretty simple. That view is returning all this information. But again, I'm curious. I want to see more. What if well, let me try looking at one of these objects. Fortunately, I get nothing back. But I wasn't ready to give up just yet. So I decided to do at this point was go back to my old friend, the SQL command, and there's a trick here I found out. I could go into SQL command, nothing will work the way I want. But if I go in as and I'm suddenly forgetting the term, but my slide I think has it. Yeah, we need DAC. Someone help me with DAC stands before. But anyway, if I run as the minus capital A, I can run as the DAC, and now I can actually do some of this stuff. I can actually, and I get rows back. So it's very interesting. Even though I'm as administrator here, not only do I get nothing back, I get an invalid object name, but when I run it within the DAC process, I can actually get, thank you, direct access. Yeah, it's direct administrator, something like that. It's basically the backup one when all else goes bad. And there's a whole topic on that. But the point is, I can get in there and I can see stuff I normally can't see. Unfortunately, what I haven't figured out yet, doesn't mean I've given up on this, is I can't actually go in there and get some of this information that's not available. One of these days, I'm going to figure this out, and I'll figure out what sys CLS objects is, and figure out what some of these functions are. So it's up in the chat window. Dedicated admin connection. That's what it is. Thank you. So that worked. That's great. What's that function do? I can kind of figure out what it does from context, but I've not been able to get the actual syntax of it. So is this practical? To be honest, not really. I find it fun because what it really illustrates is what Cod was saying when he first came up with the idea of relational databases. Everything is really a table. SQL Server is built on tables that are built on tables. And a view is basically a table built on other tables or stuff like that. And if you know the old expression, it's turtles all the way down, I like to think of SQL Server as tables all the way down. Somewhere that fundamentally there is some fundamental objects in there, but we don't normally see them. Now I will, if I remember to attach it, I did not. So that fifth system database is actually where, oh, wait, here it is. I cheated, I stopped the SQL Server and I reattached stuff. That's where this systems service resource database is where a few of these objects are defined, which is why you can never touch it. You should never touch it. And Microsoft basically tells you if you touch it, that's it. They're not going to help you. So if you look in there, there's really nothing to see worth seeing. But here's the views that we see in the master database. That's all really that system resource database has. So even the master database is kind of a lie. It's going back to this system resource. But let's get practical. Stored procedures. We use these all the time, though I was just told by a developer at a company I won't name it. Stored procedures are bad, they're hard to maintain, they don't help performance, and a few other things. And I just kind of shook my head and said, okay, whatever. But we're very familiar with like SP-Who2, one of my favorites. You run it. Let's see what's running on this system. This is my laptop I use for doing presentations, so I'm always surprised when I see exactly how much stuff is going on in the background. A lot of stuff in the background, sleeping tasks and all that. But here's the task that ran my SP-Who2 command. That's great. One of the things I see a lot of beginner DBAs do is, SP, it should stand for stored procedure. I'm going to name all my stored procedures that way. And again, if this were a live, well, it is a live demo. If it was an in-person demo, I'd ask for a show of hands. Who has done that or who is still doing that? And always get a few hands, a few sheepishly, because they realize I'm leading up to something, which I am. So let me pull up a file here. So I'm going to just create a real simple storage procedure. All it does is give me the master file information about the default system databases. So create that stored procedure. I'm going to execute it. Returns results. Not too surprising. This is what we would expect. Now I'm going to do the same thing. I'm going to go into the ACE database, which is for one of my clients. Doesn't matter what it is. I run it, and I get back the same results. But I have not created that stored procedure in the ACE database. That should start to tell me something's going on here. So let me actually create that stored procedure in the ACE database and then execute it. And in this case, I want the stored procedure just to return a message saying, hey, this is local. If you notice, since I'm in the ACE database, look up here at the upper left of the screen, it says, I'm using ACE. It executes the local stored procedure. If I go back into the master database, or let me pick another database, new 3, go into there and execute it. It goes back to running the one from master. So what surprises some people, and I made this mistake years ago, I'll admit it, I'll own up to this, SP does not stand for stored procedure, it's a system procedure. And what SQL will do is it will look, does this stored procedure exist in the local database? If not, look to the master and run that. Why is this important? A couple of reasons. One of them is this can be a performance issue. In the case that we had, and this literally was about 20 years ago, so you can figure out what version of SQL is on, I think 7 at the time, or maybe 2000, no, it was 2000 we upgraded to. We had a storage procedure that literally was being called thousands of times per minute. And what we're finding is every time it was getting called, it was getting recompiled. And that was giving a huge hit to it. And we realized what happened was, because of its name, SQL Server was saying, well, I got to look in the master database. Oh, it's not there. Oh, it's here. Oh, let me recompile. So we literally renamed it. We made other changes, but renaming it gave us a huge plus on that. So again, if we drop it from the ACE database, let me go back to ACE. And execute that. We dropped it, and now we execute it again. We're back to running the one in the system database. So really kind of important thing to remember is if you use the SP underscore, it really should be for a stored procedure you want available across all databases. Now, again, a caveat with this, we don't own the master database. Microsoft does. Now, I highly doubt Microsoft is going to come along and call a stored procedure SP underscore MF. If they do, next CU is going to come along and overwrite my stored procedure. Another reason to be careful what you put in the master database. Now, there's a few that are famous enough, like SP who is active, which I think is on this machine. I can't remember if I installed it here or not. Apparently I did. That probably Microsoft won't be overriding them, but be very careful naming your stored procedures and where you put them. You can get some weird results if you're not careful about that. Okay. How many, again, normally I would do a show of hands. You can raise your hand in your home office and just pretend I'm looking at it. How many people have come up to a database and all the databases are on the C drive, or maybe the D drive, because the DBA was a little smarter than your average bear. But in a lot of cases, I come in and it's the SQL Server is installed by some sysadmin who just boom, 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 hit enter to all the prompts, hit yes, hit OK, and now we've got all the system databases on the C drive. Very common problem. Now we're all thinking, yeah, I know that's a pain in the butt. I can't tell you the number of times I've had to change that. So let me close this out. And go in here. We're going to say, if I can type. And I should not be typing in the demo because I am going to mess it up. Let me go back to the file this had open. I'm going to steal that and just use my command from there. So what's valuable about this is, again, everything's a table. So we can look in this table and we see, here's all my databases, the database ID, here's the name of the database, or sorry, that's not the name, it's the name of the file in the database, and here's where that file is on the disk. Now, since this is my Surface Pro, I really only do have the C drive. I can't start putting on other drives. I suppose I could partition my disk, but it wouldn't make much difference. But I can tell, okay, these databases is my SQL data folder, this is in a logs folder, this is the default install folder. This is my demo machine. I don't really care where I put them. But on a production box, I obviously very much care where I put stuff. So moving a database, most of you are familiar with, you can detach the database, you alter the database, you can detach it, move it at the OS level, reattach it at the new location. Now, and I think it was starting in 2012 or maybe 2015, you can actually execute an alter database command, still have to then move it to the OS level and reattach it. But there's ways of doing it. But let's stop for a second and think about this. The master database. Well, again, if these two rows are, if you can see them, oops, that's, sorry. Yeah, these two rows right here, that's the master database. So the master database basically says, here's where the master database is loaded. But I can't read the master database until I've started up SQL Server. The SQL Server itself has to know where to find the master database. I'm not going to demo this simply because my attempts to demo in the past in a live demo, I've ended up hosing my SQL Server, and then it's very embarrassing as I try to fix it in front of a live audience. But to do this, the most common way, there's a document at Microsoft, basically tells you what to do. You basically have to go into the registry or to the services and say where the database is needs to be moved to. So in this case, scroll up real quick. That's TempDB. So moving the master database talks about settings, startup parameters, something like that. So there are things you can do here to move it. I've done this multiple times in production. Not going to demo it here, but it's pretty easy to do. And if you notice, if you do it with the startup flag, -D is basically the data file, and -L is the log file. Microsoft got very creative on this, very easy to do. You can also make this change in the registry, which will also preserve it. Very useful. But the master database also needs to be moved. And this one I actually decided to do a demo for. And I took this from the Microsoft page. Again, probably maybe the second most important master system database. SQL Server Agent used for scheduling alerts, other features, Management Studio, Service Broker, and Database Mail. So if you lose this one, you're kind of hosed. And what I mean by that is you've got a functioning system and it crashes, and you do all your restores, and then you find all your jobs are missing. You don't know who your alerts are going to or anything like that. You want to have your MSDB. And the other thing that happens, more so than any other system database, the MSDB database can grow very large depending on how much you store in it. I myself have a script for my largest client when we build a new server that we up the number of log files that we keep, but also within the database, the number of rows we keep for every job history and everything like that. Because, you know, I think the default is 1,000 rows of job history. If I've got 10 databases and I'm doing log shipping every 15 minutes, it's going to churn through that log very quickly. So I up all those numbers, usually by a factor of 10 to 100, so I can keep days, if not weeks worth of stuff in the MSDB. So I'm going to do a quick demo here, which hopefully will work. I realized I didn't fully test this, so bear with me. This will be fun. This is PowerShell. First thing I want to note here is for anybody not using PowerShell, again, use it. One of the really cool things with PowerShell is, so a # is a comment. If you put this in as the first line of your PowerShell, or one of the first lines, # requires run as administrator, and you run it as a non-admin, it's going to immediately spit out an error message and stop. Reason this is important is because in this script, I want to stop and restart SQL Server. And I was finding when I was doing this demo, I'd forget to run this administrator and it would start to move the files, do stuff, and it would blow me up and everything like that. So I put this little catch in to make things a little smarter here. So we're going to run this, and it pops up two windows. The first window is, hey, this is where we started. So yep, we moved the data file, moved the log file. It was in my default install directory. We're going to move it to the temp directory because, you know, the temp directory is a great place to put critical system files, right? And if you see, it stops and it restarts the service, and it popped up a window which I closed by mistake. It popped up a little too quick there. And this is telling me, yes, it actually moved it. So the previous two ones were basically like, where was it? Where am I going to move it to? But this one is an actual select statement from the system database saying, hey, where did you move it to? And we can see that. Oops. So if I look at my TempDB, oops, there it is, my MSDB, sorry, I can see I moved it on to the TempDB, or the temporary directory. Now, the sysadmin comes to me and says, Greg, you don't want to move the temporary directory. We delete that from time to time. So much for my great idea of, you know, organizing stuff. So let me listen to the sysadmin and move everything back very quickly. And if I don't do it now, I'm going to forget to do it. And my next demo will be more exciting than this one. So again, where was it? Was there? I'm moving it to here. Stopping SQL Server. You can see it stopping down there. And it's taking its own sweet time, and then it started back up. And it does a query and says, yep, it moved it back, everything is good. So again, I would recommend looking at systems and where are your system databases? Do they need to be moved? My experience is, as a consultant, in many cases, they need to be moved. Where you move them is kind of up to you, but look at them and make some decisions based on that. So let's look at the MSDB a little closer, because again, it's a really fun critical database. So drill down into it, forget the master, we no longer care about that. You know, okay, we see some tables there, but all these system tables, there's a lot of fun stuff here. And if you have not looked at this, go look at it and just query the tables. You don't really have to care too much what's in the table or what the tables are. You're not changing anything. But sysmail log, keeps a log of all my mails I've sent out. History, you know, DAC internal, I haven't even looked at that one. Log shipping, keeps track of all your logging shipping setup. Backup file group, backup files, backup set. This is very useful. And I'm going to let you in a little secret in a few seconds, but let's pull up a couple of queries here. Make sure I get all of them. So, you know, one of my things I have to do every once in a while is look at, hey, what jobs are running? What's your success rate? And this is a very simple one. For production, I would make it a little more complicated. But basically, I can look through here and I can say, oh, look, here's all the jobs that I've run. And I've, if it's a 0, it's a failure. If it's a 1, it's succeeded. If it's a 4, it's in progress. This is kind of a joke because those are the only 5 values you should ever see. If you see something other than a 0 through 4, something is definitely wrong with your database. But if you notice all these jobs succeeded, they said, oh, wait, oh, my backup failed on July 20th. Tried running for, can't remember that seconds, I think that's seconds, and it failed. I may have to look at that. Maybe it retried. So again, you can get a lot of this information simply by querying the database yourself. I like to get alerts on jobs. And I've gone through one of my clients and I've gone through every SQL server and basically run a query very much like this one that just says, hey, what jobs are enabled and do they send emails? If they're not enabled, I don't really care because it's not my problem. But if they're enabled and they're not sending emails, should they? Because if a job fails, presumably someone should know about it. So I actually wrap this in PowerShell, and so I can say check 10 servers just by running a single PowerShell command and go through and say, oh, I need to update these servers and make sure emails go to the right person, which 9 times out of 10 is me. But again, very simple, gives me a lot of information. I can also do an update on this. I could update all these jobs to send email if I wanted to. Some people say, oh, use the GUI for that. But once you understand the MSDB databases, you understand which ones you can modify safely and what they're doing. It's not so unsafe to do. What emails have I sent? Well, this box, again, is my demo box. Oh, look, job succeeded. I sent a backup email. In fact, that one is probably the one I sent earlier today to myself. But again, very useful information that I can start to look at. Oh, look, I sent an attachment on, I could look up the date. I don't think, oh, there's the date when I sent the attachment. So I can keep track of what's going on in my system. This is one that I use a lot in various versions is what backups have occurred. And I can look at various things here. D is for a database backup. But let's say I want to care about when's my last log back occurred. Well, it looks like the last time I backed up AdventureWorks log was in 2019, June 18th or June 8th. Maybe I need to start doing my backups on a more regular basis. I use this a lot. I have a stored procedure at one of my clients where their dev system, the developer can run a stored procedure, say, hey, what's the latest 5 backups from the production server for this database? Shows them the latest database backups. They can click on the way they want and they can restore that to their local system. Kind of their way of being able to pull down the latest and greatest data and everything like that. So the important thing to understand is once you set up the permissions, you can have a job on, say, your dev box, query another box and get a list of all your backups. Now here's the thing. I'm sure everybody out there, they've either are using or have used Redgate, Minionware, or some of these other products. A lot of companies have things that will give you all this information. 9 times out of 10, 99 times out of 100, this is what they're doing. They're not doing anything special. They haven't paid Microsoft under the table to get a special API. They're simply querying the proper tables to get the information that you need and presenting it in a format that is useful for you to understand. So, especially in smaller shops where I do a lot of my work, where they can't afford some of these tools, or my largest shop where, trust me, they can afford these tools, but they don't allow us to buy them. I've had to go out and kind of roll my own of, how am I going to monitor some of the MSDB stuff between my servers. So I could go on all night, all the stuff that can be done with MSDB, but I'm not going to do that because we got other databases. Let me clear out here for a second. And, okay, what else we got here? So as I said, your backup information, you restore it. That's another important thing. I'm going to go on a little side rant here, one that I have another talk on backups, but is a wise sage once said, nobody cares about backups. It's the honest truth. Backups don't matter. Restores matter. And I have known cases of people have been religiously doing their backups, never tested them, and when it came time to do a restore, found out they couldn't do a restore. So, you keep track of your restores. One reason I love log shipping, by the way, is because I'm automatically testing my restores every 15 minutes or every hour or everything like that. But anyway, you can see all that information. Let's poke around. We already did. So create your own. I would love to see what scripts are out there that other people come with for monitoring what they monitor. Log shipping is a valuable one. Yes, Microsoft has some good tools built in there, but again, you might want to roll your own to get more detailed information or send alerts when certain events happen. Oh, we already did the MSDB. Let's use PowerShell. I'm sorry, I got ahead of myself here. TempDB. I actually was presenting this, I want to say Colorado Springs. No, everywhere I was presenting this. I think it was Atlanta, and about 2 hours before my presentation, maybe Re-Irish or someone was doing a presentation on TempDB, a whole hour long. And I've got to admit, and I know some of you folks here are also speakers, it's always a little humbling when you're sitting in someone else's presentation and you think, oh, they're doing better. They're doing that better than I'm going to do that. I'm going to have to up my game now. So I have to admit, I modified my presentation as it was being, as I was sitting through the other one to add a few things. But it's an important one. And again, I said all these system databases I could probably do an entire talk on, and TempDB is one of those big ones. And it's ironic because all too often, again, DBAs look at TempDB and said, oh, that's just kind of a scratch pad. Who cares about that? TempDB, I keep saying these are all important. Well, master is important because without it, you can't keep track of any of your databases. MSDB is important because without that, you lose all your job information, everything like that, but you could probably handle things. You can't run SQL Server without TempDB, but more importantly, you can't run it quickly without a good TempDB. And this is something I think a lot of DBAs overlook. And the advice I saw, and mentioned here is the bullet point, use your fast drives. Yes, really. And I never thought about this because I'd seen a lot of DBAs say, oh, I just kind of put TempDB over here. I don't think about it because, who cares? It's just a temporary database. I want my data on the fast drives. And there's an argument for that. But if you think about it, you've got 5 user databases. All of them at some point are probably going to use the TempDB. So let's talk a little more about that and why I use fast drives. If you haven't, I would recommend look at your TempDB on your various servers and see how it's set up. Again, very often it's the defaults. And I will say the defaults have gotten better, and I'll talk about that. But especially if it's an older server, especially if it's built in 2012 or before, and I know some of you are running 2005 out there, you don't have to raise your hand. I don't want to embarrass you. I just got my last client off 2005 6 months ago. But some of the older ones have really poor TempDB setups, and that can really be impacting your performance. And a faster CPU is not going to help. So again, when you accept the defaults, SQL Server says, oh, we're going to put this on your install drive. Now, again, if you're installing it and you're not just hitting OK, enter every time, you probably say, I'm going to put my system databases on my E drive or F drive or whatever is your non-OS drive. That's great, but don't put your TempDB there if you can. We actually spec out from my largest client 2 drives, in some cases more, but 2 drives just for the temporary database and the temporary log file. Because we don't want any disk contention. We don't want anything else competing for the disk I/O on this. And again, if you can, split out your log from your database, because again, different read access on that, you don't want that contention. Again, fast drives. And I'm going to do a demo here. I'm going to talk about the impact of fast drives on this. It actually, I had to rewrite part of my demo because of drive speed. And again, I said this on the last screen. Everything uses TempDB. If you've got 10 user databases, great. You got 10 user databases using TempDB. If you've got 1,000 users and they're doing complex queries, they're probably going to use TempDB at some point. So this is one area where Microsoft has gotten much better at. Back in the old days, and I've got enough gray hair now, I guess, to say I can remember the old days, you installed TempDB, installed SQL Server, set up TempDB, you had your TempDB file and your log file, and that was it. And that was good. And back then, it was good. In the 32-bit SQL days, when we could only access 2 gig, or if it was tricky, 3 gig of memory, that probably was sufficient. We had 1 CPU. Maybe if we had spent lots of money, we had 4 CPUs, but that was a really hefty machine. The ones I was buying with 4 CPUs were like $40,000 a piece, quite literally. So that worked pretty well. Then we started getting machines with more CPUs, and for the longest time, the advice then became, oh, have 1 TempDB file per CPU. And that works great, up to about 8 files and 8 CPUs. The reason that works, by the way, is, and getting into internals, and again, some of this has changed, but basically there's a worker thread that basically handles disk I/O, and SQL Server is kind of smart enough to say, hey, I'm going to spread those worker threads out per CPU. So I don't want to say each CPU gets its own TempDB. That's not accurate, but the I/O does get balanced that way under the hood to an extent. Again, that worked well up to 8 files and 8 CPUs, but now we have systems that routinely have 32 CPUs, 64 CPUs. I've got a system that has, I think, 128 CPUs. And what we're finding in most cases, or many cases, when you start to have that many files, SQL Server starts spending more time figuring out which file should I write to and causing more overhead that way. But again, experiment. You may have that edge case where you need more files. Let's see what the next slide is. I'm not going to talk about moving it too much. So let me do some demos here, and I'm going to talk about some of the impact of TempDB and fast drives. So bear with me as I open up these files. I'm not going to use most of these files. It was just easier to open them all than try to remember which ones I need right up off the top. Now, oops, I keep doing that. In the old days, again, a lot of stuff is the old days, one of the things that Microsoft did, and I never liked this, is this. Notice how the primary file, and ignore the other ones there, they don't exist. The auto growth was set by 10%. There's a problem with this, and I'm going to try to demonstrate it in this next demo with why I'm not a big fan of that. But the simple reason is you don't control how fast it grows. When I'm at 10 meg and I say grow 10%, I'm going to get a 1 meg extent added to it. And I'm at 11 meg. Next time it grows, it's going to be 1.1 meg added to it. So I'm now at 12.1 meg. Now when I'm at a gig and I have to add 10%, I'm going to add a huge amount of file to it. And SQL Server will come to its halt at that point. So what I've noticed they now do, I think it started 2016, and I like, is they actually set it to a fixed amount, so you always control how much it's growing by. If you don't have that as a fixed amount, I highly recommend it. So let me find the first thing I want to demo here. Sorry. So I'm going to do a real quick, stupid thing. I'm just going to create a temporary table with 10 million rows. I'm going to go through this, and let's see if I can get here in time. You'll start to see these. Oops, it may have already. It fit within TempDB. It took about 7 seconds. This isn't so bad. I mean, 10 million rows in 7 seconds on a Surface Pro. I'm kind of happy with that. The problem was, what I was trying to demo, I wanted to take more time. And remember when I said on fast drives? So I developed this demo on my home server. Like, any good DBA, I've got a server in the basement, don't we all? And I ran this, and it took like 30 seconds or something like that. Like, okay, good, I can show what I want in there. I moved it over to my Surface Pro, and it took 7 seconds. Like, huh, my Surface Pro has a slower CPU. I'm like, my Surface Pro has SSD drives. My home server has spinning disk. The resulting speed difference was dramatic. So I actually moved up to, I do this demo now in some cases with 10 million rows. And now what we should start to see, I may not have the right TempDB set up here. That should start to grow on that, if that's, yeah, I'm going to have to, sorry, I forgot to run a script before this demo. Let me see if I can stop that. a second here. I'm going to have to cycle this SQL Server. Oops, let me do one thing here. So it's still got that 10 million row database in there, so it's trying to move all that. There we go. That's a little better. Okay. So I'm going to go through. I'm going to run another quick PowerShell. This is a script I wrote tonight. All the script does is just stop SQL Server and restart it. So I start from a clean slate. And so notice my TempDB file is much smaller than the log file. Now we're going to run my which one is it? Sorry. Okay, ignore these errors. Some of those errors are intentional. So I basically added a couple of files, NDF files or extra log file or data TempDB files of 10 gig each. And now we can try running the 100. And what we should start to see, I'm still concerned that it's in theory, and I'm not seeing this happen, and I think I know why, it's should be growing these equal amounts each time. I think what's happening is it's getting smarter than me and trying to put everything into the this third file here. I apologize. I tested this before, but clearly didn't set up the files the way I wanted to. It's trying to empty out that TempDB file there. There we go. Let's try this again. Okay, now, good. We have two files the way I want them. I'm going to add my other files. And I can see them there. They're all 10 gig in size, which is what I wanted. And now what we should start to see is, you'd notice, and it may be hard to see, but they're growing at 10 megas time, because I basically said, whenever you need more room, add about, let's say 10 gigabytes at a time for this. But what's happening is it's increasing these files. And I've tested this on the SSD, and there's not much overhead on this. But on a spinning disk, this query, because it has to wait for the disk I/O to return, will take minutes to run when it has to increase those files. Right now, it'll take about 45 seconds, so I have to fill this with 45 seconds of talking. But again, I'm spreading this out across 4 files equally. This helps performance when things have to grow. But ideally, what I really want to do in the first place is I want that TempDB to be large enough for pretty much anything that's going to happen. Let's see how we're doing there. These grow to about a little over, I think, 1.2 gig in size. So we're a little over halfway there, so bear with me. And notice my temp log is also growing, because it's got to record everything that's going on, but it's growing much more slowly. And remember I said I'm an operations side DB, I don't code. I just have to say, I saw this from, it's been gone. I could not have come up with this query myself. Don't ask me how he came up with it, but he's a much smarter person than I am when it comes to it. So in this case, this took 90 seconds. That's longer than it was taking me when I did it in the past. So let's try, bear with me, I'm going to try this experiment one more time. If we get lucky, it'll work the way I want. But on my spinning disk, that is much slower, because every time it's got to extend that, this disk is literally 10 to 100 times slower than my SSD. And this is not a super fast SSD. those of you who have worked with some of the super fast SSDs out there will understand that they're operating, almost at the speed of memory at this point. So that's why if I can put my stuff on a fast SSD, I will. Oops, sorry, I have to add the files first. Oops, did I do the wrong one? Okay. So now my files are 1.2 gig. Let's run that 100 setup again and see what happens now. It may actually be faster in this case because I was seeing 42 seconds earlier. So hopefully it doesn't take 42 seconds this time. Or I should say, hope it doesn't take 90 seconds this time because I don't have 90 seconds to fill with this. But this was the one I said earlier when I ran this on my desktop. I did 10 million rows. It was fast enough. I did it on my Surface Pro, and I had to literally increase it from 10 million to 100 million in order to make a useful demo. I originally started this demo with 1 million rows, and on the Surface Pro, it quite honestly was just too fast to demo. So I use that as an example of why I like to have very fast TempDB disks. If you notice, we're not seeing any growth here because we already sized the TempDB to be large enough. And somehow I set up my, oh, there's the time up there. We're already up over a minute. So I'm gonna have to figure out why this query is taking longer than when I was testing it earlier tonight. I'm gonna blame Zoom. Zoom is using my CPU or something like that. That's what it is. But yeah, maybe I'll put this on external storage sometime and I can show that because that'll also show the performance change. So yeah, we didn't see much of a change here, but trust me, on spinning disk, you would see a large change there. So the Model DB, this is kind of the final one I'm going to talk about. This is kind of my favorite database. I keep saying that. I'm not going to say it's my favorite database. It's one that, kind of like TempDB, I think many DBAs kind of look at and don't think about much. And I remember sitting there one day saying, why is it called model? Of all the things, why call it a model? And I realized that I've been really missing out on a lot of the functionality of it. And I could start to use some of this functionality in some of the stuff I was doing. And hopefully most of you are saying, yeah, Greg, we know this, but for those of you who aren't, I think you'll find this quite useful. I'll just close this stuff out. Open up a couple more files here. Oops. That's not what I want to do. Okay. So when we look at the model database, it's a pretty boring database. I mean, as databases go, if someone said create the most boring database you could, that's probably the model database. There's really nothing in it. And when we look at it, it's, again, pretty generic. Oh, apparently I did back this up today. That's a good thing, I suppose. Pretty generic, nothing special about it. So, but what happens is when we create a new database, and again, let's be honest, we're all DBAs here, we're all friends. A lot of times we don't bother scripting stuff out. We want something quick and dirty, especially when a developer's bugging us. And we just do that and we've got a model database. And again, nothing unusual about it. Pretty generic, all the settings here. But what happens is, let's say use model, alter database, set recovery full. Oops. Okay. Oh, helps if I put them. So now let's do that exact same command, or it's not really a command, I suppose, if we are doing through the GUI. Create the script. And I have no idea why that's taking so long all of a sudden. I forgot about that. Sorry. One thing I did learn with this is you can't create a database through the GUI if the model database is in use. One of those things I keep forgetting about till it happens to me. But now when we look at the properties, notice that the recovery model is full. Basically, any property of the database that we set in the model database, when we create a new database without scripting it out or overriding it, will pick up that thing if we change the compatibility level. Why is this important? Because if you do a trivial upgrade, you may have your compatibility level still set to an older version of the SQL Server, and all your new databases are coming out with that older compatibility level. Or in dev, you probably want simple, but maybe you do want full. Maybe you want bulk logged. Maybe some of these other settings for your particular organization, you want all new databases to have a different setting for that. Change the model database, back it up, and your new database have that. But it's more than just that. Again, let's use the model database. I'm going to create a couple things here. So what I've just done, nothing too special. I created a procedure called get tables. I've created a demo table, and I've created a user. And again, because I'm being lazy like many of us are, create my new database, and we look in there, and there's my new table. Oops. And it's exactly as I defined it. It's got one column in it called Bart's identity column. It's a pretty useless table, but hey, I'm awfully proud of this table. And we said we've got a procedure in there. So let's go to that database. What did we call that? New model 5. Oops. And we're going to exec get tables. And it shows me the tables in that database. I just created a stored procedure in that database when it was created. And if I look at my users, there's my test user, and because I want the test user to always be in certain members, yep, he's DB writer, DB reader, voila. So again, I've talked to a number of DBAs, and they're one end of the spectrum, the others. Some who are like, well, yeah, Greg, obviously. But honestly, like myself, for many years, I just didn't think much about the model. Certain things you can't do, I've discovered. One thing that you can't do, which would be really nifty, and maybe I'll create take it with Microsoft, is you can't have it automatically create a file group for you. That is just one thing that it doesn't let you do. But most other things it will let you do. And in fact, let's take this one more time. So we're going to create one more database. We'll call it new model 6. We're going to script it out. Basically, this is, this is all it's running, but it's basically taking this information and using that to create the new database. So pretty much anything that you see in here, it can use to create the new database. And I've used this, I don't say lots, but I've been using this more and more at one of my clients on the dev box, so that when the developers create new databases, they create them the way I want. Because again, the developers aren't caring about where things are put. They're not caring about compatibility level or anything like that. They're simply caring about creating a database so they can start putting tables in it and doing their stuff with it. So that's why it's named model for a reason, because it is the model from which other databases are created. So I showed simple recovery. I did not show compatibility mode, but you can take that from the example I gave, stored procedure, create a table. And that's really it, folks. At this point, contact information. I forgot I did do a podcast once with the SQL Data Partner folks, so that's always a good thing. But at this point, I want to open things up to questions, comments, input, feedback, anything like that from anybody. Thank you.
Greg, thanks for your time and your presentation. Good stuff.
Thank you. You're welcome. So, thanks, Todd. You're welcome. Any other questions or comments? Hopefully I didn't put everybody to sleep. That's the problem with virtual presentations. I can't tell who's falling asleep or going to get ice cream.
I appreciated.
I will take that.
I appreciated your ability to, deal with difficulties on the fly and solve them and handle them well.
Oh, that's an interesting one. Didn't even think about that. Todd says when you create a new DB in Azure, defaults to TD enabled. I have not played with TDE, so I'm going to have to play with that, see if the model does that. Be kind of good if it would. Well, thank you, folks. I enjoyed presenting. I would much rather love to come back out to Denver again. It's a great city, but in this time of COVID, I don't think I'm going to be traveling anytime soon, unfortunately. But I will echo what. Yeah. Actually, we're starting to get smoke out here in Albany. It's been hazy the past 2 days. So we're seeing a little bit of it. Not like what you folks are, my friends in California and Oregon and Colorado are. And I want to echo what Leslie was saying when I joined at the beginning of this whole thing is, for those of you who have not been to SQL Summit, I am definitely going to recommend it. I know virtual is very different, but it's a great opportunity. And as I tell everybody, hey, this year you get access to all the recordings. So even if you got 3 things that are happening at once, which trust me happens at the real summit, you can still go attend one live and listen to the other 2 later on. So I'm very much looking forward to SQL Summit this year, even though it's virtual, and I think it's going to be a great opportunity. So hopefully I see a bunch of you there virtually.
Thanks, Greg. Yeah. I already registered, so I look forward to attending too.
Excellent. Todd, I'm sure I'm going to see you there.
Yep.
So, and I will be talking about PowerShell there for anybody interested. So thank you very much, folks. I'm going to sign off now, and hope you all have a good evening.
Thank you, Greg.
Awesome.
Appreciate it.
Thanks, Greg.
So much, Greg.
Okay. Yep. Thank you.
Good night, everyone.
See y'all.